Hello everyone, welcome to the channel. I'm Kelvin. This is the Freewing 90mm V2 F16 that I purchased from Motionrc. I did a FPV conversion on this model and I posted some of the videos from that on some of the groups, and there was a lot of interest in it. So I'm making a video here to kind of go over my setup in this particular model and do a deep dive into all the systems and components that I have in the aircraft. And then I'll also do a in cockpit flight where I'll do a commentary voiceover over the flights and explain to you guys my process of flying it, some of the what the OSD elements that you might see in the screen, what those represent, and then we'll dive into the aircraft. I'll open it up and show the install on all the various components, and I'll try to explain this in much detail about all the stuff that I have in it to help you guys out if you're interested in doing an FPV model yourself. One thing that you have to understand is that this is a complex model. It doesn't have to be this complex with all of the flight controller and all the various sensors that I have tied into the airplane. You could definitely do a much simpler setup. I'll post up a picture of a diagram of a simpler setup that I pulled from the FPV combat group. You can look at that. So if you have some models already and you want to get like a set of goggles, maybe and a video transmitter and the BAG gimbal set from Motionsic RC, you can use this guide to set up your model and just get flying with the basic setup. Me personally, I like a more complex model. I like to have the canopy on it so that when I put the goggles on, I look out, I can actually see the canopies there. It looks a little bit more realistic. I like to customize the cockpit to make that look as realistic as possible. For example, on this one, I added the FPV Toys LCD display that gives me various data from the flight controller onto the screen, which looks pretty cool. And I try to keep everything contained in the aircraft so that when you look at it, it looks clean and like it was supposed to be that way. So let's go ahead and get started with that in-flight video, and I'll take you guys through that process and explain how that goes. So I've armed the plane and I'm going to taxi out to the runway. I've got a couple of people there watching. My wife is filming. We'll be to the right once I line up for the takeoff. In the screen, you can see this is my gear down OSD where I have a vertical bars. I use those to help me line up with the heads-up display. If the heads-up display is in the middle of those two bars, I know that my head is straight and I'm looking straight ahead and not kind of flying with my head tilted to the right or left. It's just a little good indication for that. So I'm doing a pre-flight check, checking all of my control surfaces, making sure that they are moving properly, and I'll start preparing for flight. In the bottom left, you can see 9 with the satellite. That means I've acquired 9 satellites, and I am ready for a takeoff. So I should be powering up here in a second. I'll go to full throttle. In the bottom on the left, you can see it goes from 0 to 100. That is, or bottom center left, that is my actual stick position. And to the right of that is my amp draw. In the middle, where you see the horizon, on the left side, that's my altitude from GPS. And then on the right is my airspeed through the Pinot tube. And then up top, you can see where it says 80 mile an hour right now. That is my actual GPS ground speed. And then where you see G, that's the G forces that I'm pulling. I think that I have maxed out the F16 at about 5 Gs, but I don't think it could sustain much. It could sustain much more than about 3 to 4 Gs in a turn. So I'm flying around here, doing some acrobatics, kind of showing off for the people that are watching. This is the 19th or 20th flight that I have on it. I've done some tuning to the gyro. It's flying a lot smoother. As you can see, this is not stabilized footage and it's not doing a whole lot of shaking around. I do get a little bit of a shimmy when I raise or lower the gear. I think that's just the gear doors and the gear going out into the airstream and the gyro having it correct, but it's overall is flying pretty smooth. Do a few rolls. It has a little bit of bounce back on the rolls, meaning that after I finish the roll, there's a little bounce there. That's a little bit of tuning that I'll need to do in the flight controller software. So if you look to the bottom right, it says about 1700. It's counting up. That is the milliamps that I have pulled on the flight pack. That's my indication to let me know when I have depleted the battery. So if I'm flying with like a 6,000 milliamp pack, from experience, I need to be landing at no more than 4,500 milliamps drawn. And then on the bottom right is my where it says 3.8. That's the actual cell voltage per cell. That is not the most accurate way of checking your battery, because anytime I pull a lot of amps, obviously that voltage is going to sag a little bit just from the amp draw being high. This plane is pretty efficient. If you notice, I'm full throttle right now, pulling 118, 120 amps. I wish it had a little bit more power. I kind of fell off at the top of that split S, but you know, it just is what it is. So right now I'm flying around, and you know, at 2,800 I have enough time for maybe a few more passes before I need to start preparing for the landing. But it's flying pretty good. You can see the FPV Toys display there. That's getting real-time data from the flight controller, and it has a little bit of delay to it, so I wouldn't necessarily say you can use it for, you know, you're flying, because it's a little bit more delayed than like the artificial horizon and the OSD, but it's still a pretty neat thing to have on there. So now I'm coming around. As you see, the OSD has changed because I have dropped the landing gear. I have those vertical bars now that help me line up for the runway when I'm coming in for a landing, and I have a little bit more data up in the screen for my approach. So I've dropped the gear, I've hit the switch for the air brakes here. Plane is slowing down nice. Airspeed for landing for this plane is about 30 miles an hour. And we've set down for a nice touchdown here. Try to hold the nose up a little bit, but I just didn't have the energy to keep it there. So now that it's landed, got a little bounce there. Our runway is not the smoothest runway. I'm very happy to be fortunate enough to fly to place with the runway, but yeah, it's not smooth at all. So I get a lot of bouncing. But yeah, I'm taxiing back now, and you know, I'm sitting in a chair to the left of the screen now, by that last pavilion. I'm sitting over there with my other friends that are watching me fly, and we're gonna taxi on back to the taxiway, and that will conclude this flight. Hope you guys enjoyed. Well, I hope you guys enjoyed that flight. I'm going to start talking about the gear that I have in. I'll start with the transmitter and the goggles. So I'm going to rotate guys over here to the bench. And this is what I'm flying with. So I'm using a new transmitter for me. I've been flying an FR Sky QX7 for like 7 years on various drones and stuff. And I was using that in the F22 over there. But I decided it was time for a radio upgrade. I like this Jumper T15, and that's what I'm using. It's a pretty new radio, not very expensive. I think $170, $150, somewhere around that range. It is using the Express LRS protocol for you know, the receiver and the transmission. And the goggles I'm using, as before with the F22, I'm using the Dji Goggles 2. And this is the Tally head tracker. I have it mounted to the top of the goggles. And if you buy it from Motionsic RC, they have it mounted here in the front. These are actually antennas that are behind the plastic here. They're patch antennas that have a high gain in a straight direction coming from there. So I didn't want to block the antenna. So I just designed this little mount. This double sticks on the top of the goggles and mounts it horizontally. This is one of the items that'll be on Thingiverse if you guys decide you want to go this route rather than mounting it on the front here. So these are the goggles that I'm using. And this is a transmitter basically. So the way this all connects here when I'm ready to fly is I have this regular 2.5 millimeter, I think it's 2.5 millimeter. It's a mono jack plug. So that plugs into the trainer port on the top of the radio. and then it goes into a port on the side of the Tally head tracker. So the purpose of that is, this is just as it moves around, like as your head is moving, this is turning that movement into a PWM signal, kind of like what you would have from your stick controller, and it just runs it through a trainer port, and then that is being just transmitted to the model. So that's the basics of how it works. There's plenty of videos online explaining how to do all of this, how to get that set up. I'll put one or two that worked for me in the description so you guys can look at those videos if you're trying to get this set up. So I'm going to go ahead and power it all up, and I'm going to show you it actually working, the head tracker and the camera movement in the canopy of the F16. Okay, I got everything powered up and going. Goggles are on. We do have video going into the goggles. I'll try to show you, but it's probably not going to be that visible here. Yeah, you can kind of see it a little bit. It's really hard to get this to show, but we have video going into the goggles. Right now, the gimbal is not working because I do not have the trainer plugged in. So I have it plugged into the transmitter. I'm going to go ahead and plug it here into the goggles. It's kind of hard to hold the phone and do this at the same time, but we'll get it plugged in. Trainer signal recovered. Okay, so now that the trainer cable is plugged in, the goggles are now, the head tracking is now working. So if we go over here, what I'll do is move the F16 over a little closer and hold the goggles here. And if you guys look, we're moving with the camera. So as the goggles move and you move your head around, you can look and see everything. On the head tracker, there's a little button here on the very top. And before each flight, when I fly, I'll get comfortable in my chair. I'll hold my head straight, looking forward, as if I was sitting in the cockpit. And then I'll just press this little button here to center everything. And that will center the camera. And then from there, this will be my center position with me, you know, sitting and looking straight. And I do that for every flight. So at the beginning of every flight, I just do a quick tap of this top button, get everything centered, and I'm ready to go. One thing that happens a lot that I don't see talked about much is when I first put this head tracker on, I was getting a lot of drift. So drift is where, say I'm looking straight ahead and then I turn and I look back at the back of it. The camera will start to drift back this way, even though I'm still looking back. So that's called drift. I found that problem was really because of the battery for the goggles here. I had it strapped to the head strap here. And when the battery is close to the magnetometer, I think it is in here, that's what it uses to help determine the position of your head. It just causes interference and it makes it drift a lot. So I used to fly drones and stuff, and I would have my goggle just my battery attached to the side of the goggles. I had to go back to having it on a long cable, and I sit the battery down on the ground, and then have the cable coming up to my head on the goggles. So that completely solved all of my drift problems. So if you guys are having that type of problem, or if anyone has been in that situation, that might be something to look at. I'm going to talk about the FPV Toys display there. So if you look there, that is the gauge display that I purchased from FPV Toys. It's pretty cool because it shows some actual flight data with little small gauges. So it looks very realistic, very cool look. So I tried to incorporate that into the setup when I built everything. This here is the ARMS heads-up display that comes from Motionsic RC. I did not have that in the F22, so I tried it in here and I'm liking it a lot. Basically, that's what gives you that little target bullseye that's in the middle of the glass being reflected off the glass back to the camera. And the idea there is that when you put that in, you want to try to have it, as straight as possible and level with the camera. I had to do a little work and tweaking just to get it to where I liked it. I really wanted to have the camera sitting a little higher in the canopy. I watched some videos of real F-16s and listened to some pilot when they talk about what it was like flying the F-16s. They always described it as, you know, like you're sitting on the front of a rocket on top of the world and you can just see everything. So I knew that, you know, to get that kind of effect, I would need to have the camera a little bit higher up. And it was a little difficult to try to get this lined up because I think it was getting really high, close to hitting the canopy. But I got it like probably a good compromise to get it where it is and still keep the camera high. So, you know, it looks pretty good and it works great. And then, you know, I center everything off in the servo midpoints to center it off to make sure that the target reflected is dead center on the camera line. So I have a bunch of mixes here in the controller for the plane. And I watched John's video. I think his name is John from Two Brothers RC. And he did probably one of the best reviews I've seen on this F-16, where he was explaining about how to make it fly good and perform well. And I like that type of content that really helped me to get a baseline of where I wanted to get the CG on the plane, what type of mixes might work. Also, you know, the control surface deflections and you know, the flight performance I can expect. So I kind of followed some of his advice. I put some of the same mixes he did, although those mixes are done through Inav. Inav is a software on the flight controller, which is basically a flight computer on the plane that's running everything. And I went for a more tail heavy setup like John recommended. He recommended, I think, 40 millimeters back from the actual marks on the bottom of the wing. I did everything I could to try to get it that far back, but I just couldn't with all the weight that I added up here with this gear, with the FPV gear. I actually moved the battery way back here, and even getting the battery that far back, it's still the furthest back I could get the CG is 35 millimeters. I've been flying it anywhere between 30 and 35 millimeters, and it's still very snappy, very responsive. Flies very good at that CG point. Although I am using the flight controller Inav software to do all the gyro stabilization, that has been you know, working really well. I think you definitely need that type of stabilization if you're flying that tail heavy, but it's going to be a lot like the real F-16, which is, you know, more tail heavy, more unstable, and it's using a flight computer to keep the plane stable. So that's what we're trying to do here. I like replicating and making the plane, you know, fly and look and perform as realistic as possible. I think that's just a really fun thing to do with modeling. So I'll talk about some of my control throws here. So I have a mix here where we have Tailorons and I think they would be elevons, or not elevons, flapperons. So I have a mix here for that, and then I have a mix where we have, when I do elevator, both ailerons, like if I go up elevator, both ailerons drop, down elevator, both ailerons go up. And then I can take that, I can flip a switch, take that off a mix. So my flight mode 1 is just basic controls. And then I have a few other mixes. So when I drop the gear, let me make sure it's safe for me to drop the gear. Let me position it in a spot where the gear doesn't snag. You guys can kind of hear the gyro moving around as I move the plane. But when I drop the gear, I'll drop it real quick and you guys will see the flaps drop. So that's just an automatic mix. Whenever I drop the gear, I drop to mid flaps. That's been working good for landing and takeoff. I'm able to slow the plane down very slow for landings, and for takeoffs, it gets up in the air very quick. So I still have my ailerons functioning even with the flaps down. And then if the gear goes up, you can see the ailerons slowly raise. So we'll do gear up now. All right, So that's a mix that I have. I do have some flight modes. I have a normal acro mode, which is what we fly in. Acro mode means that the plane is going to stay in the last position that you put it in. So if I roll 90 degrees, the gyro and stabilization is going to try to keep the plane at 90 degrees. Obviously, it's a plane that's going to fly out of it at some point, but it's trying to hold it at that last known position. That's my acro mode, and you guys saw that on the top of the on-screen display in the flight video. The mid mode that I have is the middle switch position here.
Horizon mode.
That's horizon mode. What horizon mode is going to do is keep the plane level at all times. If I go left, it'll bank left for a second and then level itself off. I think that would be similar to like AS3X plus safe mode. I'm not 100% sure because I'm not very versed on safe, but I think it's similar to that. The plane is always going to try to stay level, and then you can go into the software and change how much bank angle that you can get if you go full deflection or full up, full elevator. So you can see here that as I move the plane, the ailerons are just going to go like, like this wing is going up aileron to try to level it off, and then everything is to level when the plane is leveled. So it's just basically auto leveling. You can still do loops and rolls and stuff like that in this mode if you set it up to do so. And then my last mode is the manual mode.
Manual mode.
When I flip it into that mode, the plane has no stabilization whatsoever. So this would just be flying normal, how you would always fly a normal RC line of sight RC model. So
Acro mode on.
the last thing that I have is reverse thrust. I have reverse thrust always on a momentary switch. That way that when I come in and do a landing, I just push one button, one momentary switch, it does its thing. And then when I want to let off, I just let off that switch. So I don't have to hit the reverse thrust button and then turn around and throttle it up. As soon as I hit the the button on the transmitter, the motor will go to 100% throttle as soon as I push the button. So I'm just gonna bump it here, and you'll see, I don't want it to fall off the stand, but as soon as I bump it, you'll see all my surfaces go to full deflection to create as much drag and the least amount of lift as possible. And then it also, after a second or two, it'll hit reverse thrust. It probably won't do the thrust because it's not actually armed, but we'll see the deflection. So here we go.
Reverse thrust. Reverse thrust.
So I'll see if it arms.
Armed.
It needs a GPS signal for it to actually arm. I'm in the garage, so it might have that signal now. Let's see. Yes, so we are armed. So you'll see that when I hit reverse thrust, the motor will go full throttle reverse.
Reverse thrust. Reverse thrust.
All right, so that explains that. So those are most of the setup things that I have done to the plane. I'll start talking about some of the sensors and everything that we have. So when we're running a flight computer, we have our flight controller. We call it FC for short. We have a bunch of sensors that can be inputted into that flight controller. And some of them are external, some of them internal. One of the external sensors is the Pino tube. So that is a real functioning Pino tube there. I got the Pino tube from Matek. I think it's Matek RC or Matek Flight Controllers or something like that. But I got it. It's a Matek Pino tube, and I drilled a hole here into the nose cone. I cut this part off, drilled a hole, and then mounted the Pino tube in from the backside. And I 3D printed a little sleeve to go over it to make it look more realistic, like the real F16. That's how I get my airspeed indication. If I take this off, you guys can kind of see what's going on here. Inside here is the tubes for the Pino tube. Camera doesn't want to focus. There we go. So that's the little board, the sensor, and then their tubes go up front to the main tube there. I have my GPS antenna right here. So this is the antenna where it picks up the GPS signal. It needs that for arming. It also uses GPS. I can get my ground speed, so I can tell how fast the plane is going based on ground speed, and then the Pino tube lets me see how fast it's going based on airspeed. When I'm flying, I'm mostly always looking at airspeed. Ground speed is just, I look at it to see, hey, can I do 100 miles an hour? And then I'm looking and say, okay, I'm actually doing 100 miles an hour. So these are the two of the sensors that I have. Another sensor, I will take off the canopy here and let's see if I can show you guys. So let me take the battery out, or I'll just explain it to you. There is a sensor way back in here, and that sensor is a Hall effect current meter. So it's just basically like it's similar to like those little meters that you buy from the hardware store if you want to see if you have how many amps are being drawn through the wire, and it's like a meter that clips over a wire and you can tell the amperage or what's being drawn through the wire. So it's similar to that. What it does is I have it going around the positive lead on the battery, and it's sending that information back to the flight controller, and that lets me know what the voltage is on the part of what it does. It lets me know what the voltage is, what my amp draw is, and it also tells me with the calculation, it lets me know how many milliamps I've pulled off the battery. So it makes it really good for flying because I can look down if I have a 6,000 milliamp pack. I can look down and see how many milliamps I've drawn in a flight, and I can really fly that battery down to the last usable amount of power pretty safely. So normally if I have like a 6,000 milliamp pack, I know that if I have anything less than 1,000 milliamps left in the pack, I'm going to be in a lot of trouble. So I usually try to land somewhere around 4,000 to 4,500, milliamps is like the most I would want to go. And I'm just watching that, that amp draw or milliamp usage go up as I'm flying, and then I can look and see, and I just have to make note of which battery I'm using. The batteries that I'm always using in this one, because I can't really fit anything much bigger, is going to be like a 6,000. So we have that sensor in the back. So those are the three main external sensors that are being run into the flight controller, and this is the flight controller right here. I also have the receiver, the ELRS Express LRS receiver. That is this guy right here. The antenna goes up, and that's how I'm picking up all my signals from the transmitter. Now the transmitter on ELRS, this is a S-bus type receiver, so it's just taking all the information that I'm sending from the transmitter and transmitting over a single wire going into the flight controller, and that's going to decipher all of that and output to all of my servos. So there's not going to be a standard receiver like you would see in a regular line of sight model that has all your receiver outputs, all your servo outputs. So that's what that guy is right there. And then just like the F22, I have a voltage regulator. This is just coming straight from the battery, power and ground going into this regulator, and it goes out to the fan here that's on the bottom of the canopy. And let's talk about this canopy really quick, and then we'll move back to the setup inside the F16. So in the canopy here, we have a few things going on. We already talked about the FPV Toys LCD display that's in there, the ARMS heads-up display. These things are pretty straightforward. I'll talk real quick about how they're wired though. The ARMS heads-up display is very simple with the way it's wired. Coming out the bottom of it, that is this little tube part right here. It's like a long shaft, so you can kind of see it in there. Coming out the bottom, it's just powered off 5 volts. So you just want to run 5 volts in there. Don't want to run any more than that because it'll burn it up. So it's just going to a 5 volt output here on the flight controller. And there's lots of different outputs on the flight controller. I just had to find something that wasn't being used and that was regulated at 5 volts, and I just wired it straight there. So I had no problems there. The FPV Toys LCD display. You can see the back of the display mounted right here. It has its own set of proprietary cabling wiring that goes into this. Looks kind of like I forgot what they call these things. It's a little board here that they have that's all pre-programmed. The way it works is it has 5 volts and ground that goes into this board, and then there is a TX and RX data wire that goes to the flight controller. So the flight controller is basically sending all of its information straight into this board, and then this board is making it be showed on the screen here. So it's all pretty straightforward, and not really hard to set up. And then we have our O3 air unit, which is the video transmitter. So the video that's coming into the camera goes into this O3 air unit from DJI, and then is being transmitted through this antenna that's right back here. Okay, so that's its own system, and that goes straight to the goggles. The way that we get all of our on-screen display, the flight controller will send data to this air unit through a TX and RX wire here coming out of the air unit, and that data will be overlaid on top of the actual video image that's being transmitted to the goggles. So that's how I can see all that information in the goggles while I'm flying. The air unit will work on anything, I think, from 2S to 6S. So I have it flying using a regulated output on the flight controller. It's already preset for that, for like DJI or Walk Snail or HD0, whatever. It's already preset to have a dedicated power output. I think the default is 9 volt, but you can solder a little jumper on the bottom of it to change the 12 volt. I upped the voltage just so it'll be a little less amp draw. So that is so that's your main connections here for the air unit. The thing about the air units is they get extremely hot, like so hot you can't touch it, and they get hot really fast. So if I had the air unit on without this fan, it would go into thermal protection and shut down within maybe less than 2 minutes. And sometimes, you know, it takes me a minute or two to get set up before I even get the plane out to the runway. So I had to come up with a method to keep it cool. And this is something that I designed. And, you know, every 3D, like I said before, every 3D printed part that you see on this plane, it's all going to be available on Thingiverse. So this part here is just that duck thing that I designed, same one like the F22. It has this 40 millimeter fan that's brushless, and the air unit sits in there, and if you can look in there, you can see the heat sinks there that I've added. So it's got some heat sinks top and bottom. Those heat sinks, I think they're 5 millimeter by 9 millimeter, and you can get like a pack of them on Amazon for like $6 or $7. I will post that link in the description as well, but these heat sinks are very key to how efficient this works, because it's just taking air. In the case of the F16, it's taking air and blowing it across, and it's just those heat sinks are you know, the heat is radiating from the air unit to the heat sinks, and the fan is cooling the heat sinks down. And that works good because I can have it on indefinitely and it just doesn't overheat.
Inactivity alarm.
I can have it on indefinitely and it just doesn't overheat. And so that's been working really good. Then in here we didn't talk about the gimbal, but this is the Motionsic BAG gimbal. Very great design. I think that if you guys are looking to do any type of FPV setup like this, this is like a must-have. It has 2 high-quality servos in it, and you get your pan and your tilt. Works very good, very seamless. I do have my own method of mounting it. The BAG gimbal from Motionsic is kind of made a sandwich onto like a flat plate, and you put a screw on the top. But I like to run a canopy on my models. Like, I just think that adds to more realism having a canopy on there. But if you do that, that means that if you had to take it out, you would have to get to the top screws to take the gimbal out for any reason. And once the canopy is glued on, I didn't want to have to worry about popping the canopy loose every time I wanted to take the gimbal out to access the screws on the top. So what I came up with was, there's a little square piece of 3D printed plastic that I made that I countersink into whatever model I'm going to do. And then once I countersink that square in there, I glue it in. I can mount the canopy, and then I can just load the gimbal in from the bottom. So once I unscrew this air unit, this comes off, and then I could pull this whole, take these 4 screws out, and the whole thing just comes out from the bottom, and I never have to take the canopy off. So that's my method, and it works. It also works good because it doesn't matter if the surface is flat or not. Even if you got like some ridges or something on there, once you just cut that square all the way through all of that, glue it in, then you can just drop it in and out. So it doesn't necessarily have to be flat. So it works pretty good. So you guys can check that out. Check that out if you're interested in doing anything like that. You guys, please excuse my camera skills. I'm trying to talk, use the camera all at the same time. Not the greatest at it, but I'll get better as I make these videos. So moving back to the F16, we'll talk a little bit about the wiring of the flight controller and the servo outputs and all that stuff. So that was probably my most unfun part about doing this whole job. I could not get the CG far enough back with the battery up here. I mean, I sat here and I looked at this thing for hours trying to figure out how am I going to get more weight to the back, and the only way I could do it is just move the battery back. But normally I was going to put all of the stuff here where the original blue box from Freewing was, and where and put the flight controller where your receiver would be. Well, if I put that there, that means the battery had to be up here, and it wasn't CGing where I wanted. And then this air unit on the bottom is so big, you know, I had the air unit like up high and it was hitting. I couldn't close the canopy. This the bottom of the arms reflector sight was hitting the battery, so it was propping the canopy. I just couldn't make anything work. It just wasn't happening. And the key to it all working in this particular model was me cutting out all of the foam back here, making a new battery tray and pushing the battery way back there. So once I got the battery pushed back, I had to extend all the servo wires and run them to the blue box and to the flight controller up here. I made this little plate to make it easier to assemble, because by 3D printing this plate, I could sit it on a bench, wire most of the things up together, then put it back in and just plug in the servos. So that worked out. That made it a little bit easier for me because I could work on it on the bench rather than trying to do all this in the model. But that was my solution. So once I got the battery pushed back, everything, it CG'd really well. I was able to get CG further back. So I had to cut out a lot of stuff. I will pull the battery out. Let me pull the battery out and then we'll look at how I have that mounted in that tray back there. Okay, so I pulled the battery out, and this is the tray. So this is a little tray that I designed and 3D printed, and it just glues in. And I had to cut there was the little piece for the original heads-up display that lit up on this V2 F16. So I had to cut all of that out. This cut is really nasty because I tried to mount that sensor right here and it didn't work out. So that's why it looks that way. But this is the tray. I had to cut all the foam out down there. This actually battery sits into the ductwork going back to the fan. So I tried to open up as much of the foam in there as I could to try to make sure I had enough airflow going in there and I wasn't blocking it. I don't think it's blocking it that much. Maybe that's the reason why the plane doesn't have a lot of instant thrust, but based on the reviews, everybody's kind of saying the same thing. So I don't think that this is having any major effect on the flow going to the fan. But that is what it is. I will try to get this camera a little lower and maybe you guys can see what's going on way back there. Let me get a light. So I got a light in there. And if you look way back there, it's hard to focus, but you can see the sensor for that's a sensor for getting the current meter, and all of that is up there. I opened up a good bit of foam there. I tried to push all the wires on the side to keep it all neat where I didn't have a bunch of wires down in the ductwork. So it's really clean. It's really neat. It just was a lot of work. It wasn't something that I really wanted to do, but it was the only way I could think of to get it all to work out. So let's talk about our servos and what's going on with the blue box and our flight controller. So the flight controller has, I believe, 10 servo outputs, and then it has 2 motor outputs. I don't think that you can use a motor output for a servo output. So one of the motor outputs is just not being used. The other one is being used to drive the ESC. And then we have a bunch of servo outputs. So what I did was I ran aileron 1, aileron 2, elevator 1, elevator 2, straight to the flight controller, right? So that way I can do the mixing, do everything I need on that. The rudder, it still goes to the Freewing blue box, and the nose gear steering goes to the Freewing new blue box. And then I have the input of the blue box goes to a rudder output on the flight controller. So just like it was a receiver. So I kind of left that as it is. Both of the air brakes, they both go straight to the flight controller, and they really didn't need to run them to the blue box. So they're just they're Y cable together. They go straight to the flight controller. The landing gear, all of the landing gear, servo gear doors, all of that goes to the blue box because it handles all the sequencing. And I just ran the gear input on the blue box to a gear output that on the flight controller. And you assign all the outputs on the flight controller in the software. So that's basically how I have everything wired. I still have all the LED lights, the flashing lights, all that stuff is still being controlled from the blue box. One thing to note is that when you're doing it this way, I am no longer using the BEC and the ESC for anything. So I basically have that BEC wire, the red wire that's on the throttle input pin on here. You would have your signal, your power, and then your ground. That power is actually the output from the ESC for the BEC. That's not connected because we're using the BEC built into the flight controller. And the flight controller basically gets power straight from the battery. So as we go to the ESC, we also Y cable off of this, and we go straight to the flight controller, and it's getting this power. This little capacitor there is just a basic, like if you put a capacitor on these, it's just jumping off of the power inputs on the flight controller, and it just helps to keep a stable voltage going into the flight controller. Also helps prevent a big spark every time you plug this in. This is a 50 volt, 1000 farad capacitor. I think it's high ESR, which means, I don't know exactly what it means. It's just a better quality capacitor. So that's how most of the wiring is set up here. This little guy here, you guys might have noticed, this is just the USB that we use for flashing the flight controller. It's an external board that I have mounted vertically because it makes it easier to plug the cable in. I don't have to get in there and try to go like sideways. It just goes vertical. And that's part of this 3D printed plate that I made to make that go vertical. So that's basically most of how the wiring is. Like I said, the toughest part was just getting the wires extended. I spent a long time cutting wires, getting some basic servo cable, soldering them, heat shrinking them, running them here, then soldering them again. I probably could have just got the ends, but I don't think I had enough ends laying around here to make just new plugs. So I just reused the old ones. But like I said, you can see that it was a lot of soldering. But anyways, that was basically what I did. And it's working out good. This F16 is like just big enough to fit all of this type of FPV gear. And I think if it was any smaller, I couldn't have fit everything that I did in. But I made it work, and it works pretty good. I do have these plugs here. These plugs are the same thing like I did with the F22. There are some plugs that I found on Amazon that I pin, and it's just a plug kit. I pin these, and that allows me to plug the canopy in, and everything works together. So in this plug, I have my servo leads, I have my power for the fan, power for the arms, heads up display, power for the flight, for the VTX, and power for the FPV Toys LCD display, and then the data signals for all that stuff too. So that's how it works. Whenever it's plugged in and the battery's in, this fan is on all the time. There's no switch for the big fan for the VTX. There's no switch for it. So whenever I plug the battery in, that fan is just blowing, keeping that flight controller cool at all times. So yeah, that's the basic setup on everything. This explains a lot for everyone on how it is. It's really, it's really not that bad. It's just a lot of soldering, a lot of sitting at the bench programming, so, there's some work there. This is a more complex system, but for me personally, that's what I enjoy. I like I like the idea of building something that flies and performs, more like the real one with a lot of systems in it that are similar to a real airplane. So that's fun for me, and I like having all the tech that some really smart people have been working on everywhere, from Inav developers to the guys at Motionsic developing these gimbals and the head trackers and stuff, and Freewing putting out awesome models. So we have a lot of stuff to play with now, and do some really cool things. So this is a fun project. My next project is probably going to be an A10 that I've got the Motionrc A10, the 80 millimeter, that I've been flying line of sight for a while. I was planning on doing that FPV many years ago, but the equipment that we were using analog cameras and all that stuff, and I didn't feel like it was going to give me the experience that I'm looking for. Now that we have digital, it's much better. So that's probably going to be my next build. I'm gonna do that, and then eventually I'll do I'm thinking of doing like a Tucano, and either Tucano or a T38, not T38. I can't remember which one, but I'm thinking about doing like a twin seat trainer plane and having 2 goggles on head trackers so that I can take people up and let them fly and let them see what it's like to fly an RC model FPV with the head tracker. So anyways, that's all for this video. I hope I explained enough for you guys, and you kind of understand what's going on here and how I set everything up. And the next video will be the actual vlog of me just assembling and putting everything together. Thanks, guys. Happy flying.